Today we are doing 8M1 lesson 5. We're going to learn about negative exponents and the laws of exponents, and hopefully we're going to give you a little homework help too. We'll do a few proofs, make sure that you got the gist of what we're learning today. All right, let's move on. Let's get going with our sketch pad and dive right in. Okay, so all right, we're going to start. We're not going to do this lesson in this exact same order that they did in the book or in your handouts. We're going to start by proving the quotient rule, and we're going to use that then to go on and prove our rule of negative exponents and such. So let's start here. So this here is in lesson 5, and it tells us some things that we already know to be true. We know that if we multiply two numbers with the same base, that we simply add their exponents. If we raise a power to another power, we multiply exponents. And that we can also, if we have two numbers multiplied together and we raise them to a power, we can get the each of the numbers inside the parentheses raised to that same power multiplied together. So those are 3 rules that we've learned in past. These are past lessons. Now we're going to make this claim here. They just make this claim. We claim, but they don't prove it. And so what I want to do is I want to go about proving this rule so we can add it, confidently add it to our current set of rules. So let's just look here. This is not a true proof. True proofs I find get very confusing. So what I like to do is I like to prove things kind of by showing you a number of examples, and then you just kind of see that something's true. And we call that that's a good enough proof, at least at this level of math. And again, my goal is not to show you how to do formal proofs. My goal here is to help you understand just what we're talking about. So let's look at an example of something that looks like this. So let's just say that in our case, x is going to be equal to 3, and a is equal to 5, and b is equal to 2. And we're just going to substitute in these numbers because our claim here is if we have a formula that looks like this, x over a divided by x over b equals x to the a minus b, then we can just plug in any numbers for x, a, and b, and it should be true. So let's see if that's true. Let's just see if this makes sense to us. So we're going to put a 3 in for x, so that'd be 3. A is 5 over 3 to the second power. And the claim is that is equal to 3 to the 5 minus 2, or 3 cubed. This is the claim. So let's see if we believe that this to be true. Well, we're gonna show by expansion. Show by expansion. So we're going to take our 3 to the 5th, and we're going to use our rule or our definition of a power and just say, well, 3 to the 5th is 3 times 3 times 3 times 3 times 3. 3 to the second power is 3 times 3. That's just by definition. And so we are now going to do some canceling like this. Cancel a 3 and cancel a 3. Cancel this 3 and cancel this 3. And we end up, and that's now a 1 on the bottom, we end up with 3 to the 3rd over 1, or 3 to the 3rd. So we see why, I think we can start to see why this is going to be true. If we wanted to show that, x to the 4th over x to the 1st is equal to x cubed, we're going to see, does that equal x cubed? We're going to show it by saying, well, x times x times x times x. We've got 4 x's multiplied and 1 x on the bottom. And we can cancel 1 x with the other x, and we end up again with x cubed. So you can see why it has to do with subtraction. It's not, the answer is not going to be dividing 5 by 2. It's not going to be dividing 4 by 1. It's going to be subtraction, and we can see it if we expand it first and then simplify. And then we can start to use our our rule. So let's just really briefly go, we're just gonna really briefly go happy cat on this because we've actually done what we set out to do. Well, let's put happy cat right there. I told you yesterday I was gonna learn to spin him, and here we go. We can spin happy cat because this is kind of a proof. Proofs tend to be a little harder. It makes happy cat very happy. Okay, now let's move on to doing a few examples here. So let's see if you can now utilize our knowledge to find out more difficult problems. So if we know that we can divide powers by subtracting the exponents when the base is the same, then we can do things like this. 10 to the 20 over 10 to the 4th equals, and I'll let you work these out, and then x to the 9th over x to the 4th. And what does that equal? Now, you go ahead and work it out, pause the video, form an opinion, and I will give you the answers. And you don't have to do this via expansion. Okay, so pause. Okay, now I'm going to assume you're back after having solved these problems, and our answer is 10 to the 20 minus 4, which is equal to 10 to the 16th. And here we get x, and I won't even write out our subtraction. I'll just write x to the 5th. And there's the power of our rule. Now, I want to show you one more example just to make sure you really get it. And let's do this. 4 to the 7th divided by 2 squared. Uh-oh. No, let's not do 2 squared. Let's do no, let's just do a different problem. Sorry. Let's do it like this. 2 to the 7th over 4 squared. Well, we cannot use, we're going to kind of use something we used yesterday. We don't have the same base, but we can turn this into the same base, and I'm going to give you a hint. It's 2 to the 7th on top, and on the bottom, we're going to have 2 to the what? What is 4? Another way to write 4, and that's going to be squared. Right? So another way to write 4 is 2 squared. Right? So 4 is 2 squared, and our squared would come over here. And so now we can rewrite this as 2 to the 7th over, and what would our law of multiplication of our power to the power rule say? They'd say this is 2 to the 4th. Okay, and now we can say that this is, because we have the same basis, we can now subtract exponents and say that's 2 to the 3rd. Now, I just used a little building block here that in a little problem from yesterday, and I kind of forced you to, think about the rule that we just learned and apply some concepts from yesterday. So this was kind of this was a hard problem here. This was a tricky problem, but if you stayed with me through this, then good work. But you're going to need to know how to do these kinds of manipulations for your quizzes and tests upcoming. Okay, now we're going to move on. We're going to move on to proving the law of negative exponents. So we're going to come to this guy here, and we're going to prove negative exponents. So negative exponents say that x, the rule is x to the negative n equals 1 over x to the n. Or in other words, some examples. I'll give you some examples. So this would say 4 to the negative 2 is equal to 1 over 4 squared. Or 3 to the negative 3 is equal to 1 over 3 cubed. Or x to the negative 4 is equal to 1 over x to the 4th. These are all examples of the negative exponent rule. But what I want to do now is I want to I want to prove this to you kind of in a very informal way. And I want to show it to you like this. So I'm going to start with x to the negative 2. And x to the negative 2 is the same thing using our quotient rule that we just learned of x to the 3. Well, let me show it to you this way. Is equal to x to the 3 minus 5, for example, right? Because x to the negative 2, 3 minus 5 is negative 2. And now if I undo the exponent rule, if I undo our quotient rule, I could say that this is equal to x to the 3 over x to the 5, right? Because we know how to do it going this way. That would be x to the 3 minus 5, but we can go backwards like this, and then we can expand. Now we're going to go x times x times x over x times x times x times x times x, and now we're going to cancel. Cancel, 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 cancel. Got a 1 left on top, and so we have 1 over x squared. So I have shown you that x to the negative 2 has got equal to 1 over x squared. So I haven't really proved it. I've shown you, I kind of showed you with a solid example, but you can do this to prove that, 4 to the negative 2 is equal to 1 over 4 squared. You could do it the exact same way. Or you could do it to say, you could even try it with a different number, like 5 to the negative 3 is equal to 1 over 5 cubed. And you do it the same way. And you might have one like this on your homework. 5 to the negative 3 is equal to 5 to the 1 minus 4 equals 5 to the 1 over 5 to the 4 equals 5 over 5 times 5 times 5 times 5. Cancel, cancel. You have your 1 left over. 1 over 5 cubed. And now, if you got it, happy cat for you. Happy cat for you. And we're going to spin the happy cat for you. Good job. Okay, so that's the proof of negative exponents. So now we're going to go and we're going to do a few examples. We'll come back to this one in a second. So an example for you is, what is 4 to the negative 10? Well, that's just 1 over 4 to the 10th. Now notice, 4 to the negative 10 is not a negative number. It is not. 1 over 4 to the 10th is 4 to the negative 10 is 1 over 4 to the 10th, and that is equal to 1 over 4 times 4 dot 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 4 10 times. And that is not negative. It's a very small number. So negative exponents, right? Negative exponents mean small numbers, usually. Right? They do not mean negative numbers. Okay. Okay, so let's look at this. What is this number? What is 3 times 10 to the negative 2? Well, now that we know what 10 to the negative 2 is, well, that's just 1 over 10 squared. So 3 times 1 over 10 squared is 3 over 100. Well, we know from 7th grade that that is basically 0.03. So 3 times 10 to the negative 2 is 0.03. Okay, something good to remember. So let's see, I'll just ask you another one. What is 12 times 10 to the negative 4? Pause and solve. All right, we're back now. So it's 12 times 1 over 10 to the 4th, which is equal to 12 over 1, 2, 3, 4 zeros, right? This thing tells you kind of, that exponent when you're dealing with tens actually tells you how many zeros there are. So that's equal to 12, and I go 1, 2, 3, 4. 0.0012. Now it's not for 1, 2, 3. Yeah, 1, 2, 3, 4. Right. It's not for me to explain to you how this transformation works. That's something we learned back in 7th grade. And if you struggle with that, make sure you ask your math teacher about that, or you can ask me, and I'll maybe point you to a video where I've done some of this work. I have some past videos that explain some of this kind of work. But it's a 7th grade standard. Okay. Let's keep moving forward. Let's do another problem. These are, again, I'm just doing problems that are kind of from the chapter or from the lesson. So this is, what is, and then we're going to get to homework help after this one. X squared y to the negative 3 equals what? Well, that's x squared times x to the negative 3. Duh, Mr. Lipscomb. Okay, well, now we have everything we need. We know everything how to solve this problem. We have x squared is x squared. Y to the negative 3 is 1 over y cubed. When you multiply two expressions, that one of them is a fraction. You have to make sure they're both fractions. Now we just multiply numerators and multiply denominators. Okay. Now watch how this works. I'll just do a more sophisticated one right now. Let's do a squared, b to the negative 4, c to the 5th, d to the negative 10th. That's just a squared times b to the negative 4th times c to the 5th times d to the negative 10. And that's equal to a squared over 1 times 1 over b to the 4th times c to the 5th over 1 times d to the negative 10. 1 over d to the 10th. And if we just multiply all our numerators, we get a squared c to the 5th over b to the 4th d to the 10th. So notice, what has happened? We basically build let's put that in a different color. We'll say, we basically build a fraction and put powers, put negative powers on bottom with negative exponents made positive. Right? So a squared, these stay on top. And then these other ones, the negatives go to bottom with a different sign. With different sign. Okay, I'm not going to write that out. Okay, now we're going to move on. Now we're going to move on to some homework help. All right, the thing you've been waiting for. Homework help. Okay, so let's compute. Let's do this. 3 to the 4th. Okay, what is 3 to the 4th times 3 to the negative 2? Well, we can do this a number of ways. We're going to do it once using our product rule. And we're going to do it again using our negative exponent rule. And we'll see that we get the same answer. So I'm going to do the negative exponent rule first. So 3 to the 4th times 1 over 3 squared, right? 3 to the negative 2 is 1 over 3 squared. So that's 3 to the 4th over 1 times 1 over 3 squared equals 3 to the 4th over, why do I keep, I'm going to need to make this better. 3 to the 4th over 3 squared. And we can do that two ways. We can use either our quotient rule, which says that that's equal to 3 to the 4 minus 2 equals 3 squared. Or we can just say, we can expand it like this and cancel, and we get 3 squared. Or you can just write 9, right? 3 squared is 9. We can also just use this using our product rule. Watch the product rule. 3 to the 4th times 3 to the negative 2 is equal to 3 to the 4th plus negative 2. And 4 plus negative 2 is 2. So I showed you 3 ways. 3 ways to do that, which is equal to 3 happy cats. All right, let's go back. Let's keep moving. Let's do some more examples. Let's get you jamming on this homework. Now that we know that we can just add these together, positive numbers or negatives, let's do a crazy problem. Let's do something crazy. X squared times x to the 4th times x to the negative 2 times x to the 0 times x to the 9th. Now I want you to remember that this does not equal 0. So it equals 1, right? X to the 0 is equal to 1. So let's use our product rule here. So this is equal to x to the 2 plus 4 plus negative 2 plus 0 plus 9. Well, 2 plus 4 is 6, minus 2 is 4, plus 9 is 13. So that is equal to x to the 13. Pretty cool. All we have to do is just add up all those exponents. Let's do one last one. This is a little trickier. We still have to add our exponents, but you're not going to be able to solve this problem fully, and you'll see what I mean. X to the a times x to the b times x to the negative 2b. Well, what is that? Crazy. Try and solve this one. Well, what did we do up here? We added our exponents. So down here, we're going to add our exponents just the same. So you try. Pause and try. Okay, I assume you came back now, and we say, well, we're just going to add our exponents. Add our exponents. So we get x to the a plus b plus negative 2b. So that's x to the a, and a b plus negative 2b, b plus negative 2b. Right, that's like a 1b plus a negative 2b is equal to negative b. 1 plus negative 2 is negative 1, so that's negative 1b. So that's negative b, so a, well, let's do it like this. A plus negative b, and that's equal to x to the a minus b. So that last one, a little tricky, but we're going to give you a happy cat, spinning happy cat. We're going to call that a day, and we're going to come right back here, come right back to ground zero. And, oh wait, that's the wrong sound effect, because you guys are excited. Thank you very much. We'll be back with lesson 6 very soon.